93% of scientists now agree on something that once sounded impossible. Alien life is not a fantasy. It is likely real, and it may be much closer than anyone expected. For decades, the idea of aliens lived in movies, books, and wild theories. Serious science stayed away from it. Talking about extraterrestrial life could damage a scientist's reputation. It was seen as speculation, not evidence. But that quiet wall has started to break. Behind closed doors in research labs and space agencies, something changed. New data started to pile up. Powerful telescopes began scanning the universe in ways never done before. And the results were not empty, they were overwhelming. Astronauts started finding planets, not one or two, thousands. Entire systems filled with worlds orbiting distant stars. Some were massive gas giants, others were rocky planets similar in size to Earth. And a surprising number of them sat in a very specific zone, a zone where temperatures allow liquid water to exist. Water is not just important, it is essential. Every known form of life depends on it. So when scientists find planets with the right conditions for water, they are not just finding rocks in space, they are finding potential homes for life. This changed the conversation completely. Scientists stopped asking if alien life exists. That question began to feel outdated. Instead, a new and more unsettling question took its place. Why has it not been found yet? Because statistically, it should be everywhere. The universe is not small. It is almost beyond comprehension. There are more galaxies than grains of sand on Earth. Each galaxy contains billions or even trillions of stars. Around many of those stars are planets. When all the numbers are combined, the total count reaches into the trillions upon trillions. Even if life forms on only a tiny fraction of those planets, the universe should be filled with living systems. This is not science fiction thinking, this is basic probability. And then something even more surprising emerged. Life on Earth appeared very early in the planet's history. As soon as conditions became stable, simple organisms began to form. This suggests that life does not require rare or perfect circumstances. It may begin quickly when the environment allows it. That idea shook the scientific community because it means Earth might not be special at all. In fact, Earth might be ordinary. At the same time, researchers started discovering life in places that were once considered completely uninhabitable. Deep beneath the ocean, near volcanic vents, organisms survive in extreme heat and pressure. In frozen deserts, microscopic life remains active in temperatures far below zero. Some bacteria even survive in highly acidic environments that would destroy most forms of life instantly. These discoveries revealed something critical. Life is not fragile, it is persistent, it adapts. It finds a way to survive in conditions that seem impossible. That expands the number of places where life could exist. Not just Earth-like planets, but icy moons, underground oceans, harsh alien environments that do not resemble Earth at all. And then there are the signals. Strange chemical signatures have been detected in the atmospheres of distant planets. Gases that on Earth are strongly linked to biological activity. Molecules drifting through space that are considered building blocks of life. Complex organic compounds forming naturally in deep space. These are not confirmations, but they are clues. Clues that something may already be happening out there, quietly, continuously, beyond direct observation. All of this has led to a major shift in thinking. The question is no longer about existence, it is about proximity. How far away is the nearest form of alien life? Is it across the galaxy or hidden much closer, within our own cosmic neighborhood? Some scientists believe the answer could lie within our own solar system. Beneath the icy surfaces of distant moons, there are vast oceans, dark, isolated, yet possibly warm enough to support life. Missions are already being planned to explore these environments. If life is found there, even in its simplest form, it would change everything instantly. It would mean life emerges wherever conditions allow it. And if that is true, then the universe is not silent, it is alive. But here is where the mystery deepens. Despite all the evidence pointing toward life, there is still no direct confirmation. No clear signal, no undeniable contact. This contradiction is known as one of the greatest puzzles in science. If life is so likely, where is everyone? Some believe intelligent civilizations are rare, others think they do not last long enough to be detected. There are theories that suggest advanced life may exist, but operates in ways humans cannot understand or detect. And then there's another possibility, the possibility that humanity is close, very close, but not yet capable of recognizing what is right in front of it, because alien life may not look like anything humans expect. It may not communicate in familiar ways. It may not build technology that humans can detect. It may exist at scales or in environments that current tools are not designed to observe. That means a discovery could happen at any moment, not because something new appears, but because humans finally understand what has been there all along. In this video, the truth behind the 93% statistic will be uncovered. The real scientific reasons why so many experts now believe alien life is likely will be explained. The latest discoveries that are pushing this belief forward will be explored, and the deeper question will be faced, not whether aliens exist, but how close they really are. Stay with this until the end, because the final idea may completely change the way reality is seen. Welcome to the channel. Subscribe now to explore the biggest mysteries of science and space. 93% is not a random number. It comes from surveys of scientists who study space, biology, and the origins of life. These are not casual opinions. These are experts who spend their lives analyzing data, running simulations, and searching for patterns in the universe. For a long time, many of them stayed cautious. Publicly, they avoided strong statements about alien life. The evidence was limited. The risk to their credibility was real. But as more data came in, their views began to shift. Quietly at first, then more openly. Today, the majority agree on one key idea. Life beyond Earth is not just possible, it is likely, but there is an important detail that often gets misunderstood. When scientists talk about alien life, they are not always talking about advanced civilizations or intelligent beings. In fact, most of them are thinking about something much simpler.
Microbial life, single-celled organisms, tiny, resilient, and extremely adaptable.
On Earth, these forms of life appeared very early and spread almost everywhere. They survive in places where complex life cannot, and they require far fewer conditions to exist. This is why scientists believe simple life could be common across the universe. Intelligent life is a different story. It requires a long chain of events, stable environments, the evolution over billions of years, the right balance of conditions that allow complexity to grow. Because of this, scientists are more cautious when it comes to advanced alien civilizations. They do not rule them out, but they treat them as less certain. Still, even a small probability becomes powerful when it is applied to the scale of the universe. That scale is difficult to fully understand. There are hundreds of billions of galaxies. Each galaxy contains billions or even trillions of stars. Around many of these stars are planets. Recent discoveries suggest that planets are not rare, they are everywhere. Some estimates suggest there could be more planets than stars. That means trillions upon trillions of worlds. Now consider this. If even a tiny fraction of those planets have the right conditions for life, the total number of life-supporting worlds becomes enormous. Even if life begins on only 1 out of every million suitable planets, there would still be millions of living worlds scattered across the universe. This is where statistics begins to challenge intuition. Because from a mathematical point of view, Earth does not look unique. It looks like one example among many. This idea was not widely accepted in the past. It was based more on philosophical thinking than hard evidence. But today, that has changed. Astronomers have confirmed thousands of exoplanets. Many are similar in size to Earth. Some orbit stars that are older than the Sun, which means they have had more time for life to develop. At the same time, chemists have found organic molecules in deep space. These are the building blocks of life. They form naturally in interstellar clouds and on distant objects. This suggests that the ingredients for life are not rare, they are common. The shift is clear. Belief in alien life is no longer driven by imagination or speculation. It is supported by observation, data, and probability. Why? And as more discoveries are made, that percentage may rise even higher, which leads to a deeper and more unsettling thought. If so many scientists agree that life should exist beyond Earth, and if the numbers strongly support it, then something else becomes harder to ignore. The universe should not be empty. Everything changed in the last few decades. Before that, planets outside the solar system were only theories. Scientists believed they existed, but there was no direct proof. The night sky looked silent, empty, just stars with no confirmed worlds around them. Then the first discovery came, a planet orbiting another star. It was a breakthrough, but at that time, it still felt rare, almost accidental. Many believed such systems might be unusual, but as technology improved, telescopes became more powerful, detection methods became more precise, and then the numbers started rising slowly at first, then rapidly. Today, thousands of exoplanets have been confirmed, not guesses, not estimates, real planets measured and tracked as they orbit distant stars, and that number keeps growing every year. But the real shock was not just how many planets exist. It was the type of planets being found. Some of them are rocky, solid surfaces, similar in size to Earth, not massive gas giants, but worlds that could, under the right conditions, support life. This is where the idea of the habitable zone becomes important. It is often called the Goldilocks zone, not too hot, not too cold, just the right distance from a star where liquid water can exist on a planet's surface. Water is the key. Without it, life as humans know it cannot survive. With it, the possibilities increase dramatically, and scientists have now identified many planets inside this zone. Some orbit stars smaller than the Sun, others circle stars that are larger and brighter. Each system is different, but the pattern is clear. Habitable zones are not rare. They are common. One of the most surprising discoveries is that some of these planets orbit stars that are much older than the Sun, billions of years older. That means if life began there, it had far more time to evolve. On Earth, complex life took billions of years to develop. Intelligence appeared very late in the timeline. So a planet with a longer history could, in theory, host life forms far more advanced. That idea has changed how scientists think about time and evolution in the universe. There are also planets that are slightly larger than Earth. These are often called super-Earths. Some scientists believe these worlds might be even more suitable for life than Earth itself. They could have thicker atmospheres, stronger gravity to hold on to heat, more stable climates. This challenges a long-held assumption that Earth represents the perfect balance for life. In reality, there may be worlds that are even better. Another surprising detail comes from how these planets form. Studies show that planet formation is a natural part of star formation. When a star is born, leftover material begins to clump together. Over time, this creates planets. This means that wherever stars exist, planets are likely to form as well. And stars are everywhere. This leads to a powerful idea. If planets are common and habitable zones are common, and the ingredients for life are common, then the conditions for life are not rare events. They are repeating patterns across the universe. Life may not require a miracle. It may simply require time and the right environment, and the universe provides both on a massive scale. This shifts the perspective completely. Instead of asking how life could begin, scientists are now asking how often it begins, because if the process is natural and repeatable, then life could emerge again and again across countless worlds, which raises a deeper question. If so many habitable planets exist, and if some of them have had billions of extra years to evolve, then somewhere out there, life may not just exist. It may already be far ahead. The search for alien life is no longer limited to distant dreams. It is now focused on signals, tiny clues hidden in light, chemistry, and space itself. One of the most powerful tools scientists use is the study of atmospheres on distant planets. When a planet passes in front of its star, a small portion of starlight travels through that planet's atmosphere before reaching Earth. That light carries information. It reveals which gases are present. This is where things become interesting. Certain gases are known as biosignatures. These are chemical compounds that on Earth are strongly linked to life. Oxygen is one of them. Methane is another. On Earth, methane is produced in large amounts by living organisms. Finding these gases alone does not prove life exists. There are non-biological processes that can produce them, but when multiple biosignatures appear together, the chances of life increase significantly. Recently, scientists have detected traces of these gases on distant exoplanets. In some cases, the combinations are unusual. They do not match what is expected from simple chemical reactions. This raises a question that remains unanswered. Something is producing these signals, but the source is still unknown. At the same time, strange signals have been detected coming from deep space. Short bursts of radio waves, repeating patterns. Some of them are incredibly powerful. These are known as fast radio bursts. Most are believed to come from natural cosmic events like neutron stars or extreme magnetic activity, but not all of them are fully understood. A few signals show patterns that scientists struggle to explain clearly. There was Eve, and a moment when a signal from a nearby star caused brief excitement. It appeared narrow and focused, unlike typical natural signals. For a short time, it raised serious questions. Later, it was traced back to human technology, but the fact that it seemed unusual at first shows how close the line can be. And then there are the molecules. Organic molecules have been found drifting in space, not just simple ones, but complex carbon-based compounds. Some are similar to the building blocks of proteins and amino acids. These are essential for life as it is known on Earth. They have been detected in interstellar clouds, on comets, and even on distant moons. This is a critical detail. It means the ingredients for life are not limited to planets. They exist throughout the universe, forming naturally in space. Some scientists believe that life on Earth may have been influenced by these molecules arriving from space long ago, carried by comets or asteroids. This idea is known as panspermia. If that is true, then life is not just forming in isolated locations. It could be spreading quietly, slowly, across vast distances. All of these discoveries point in one direction. There are signs, not clear answers, but signals that something is happening beyond direct observation. The challenge is interpretation. Science requires proof, clear, repeatable, undeniable evidence. A single signal is not enough. A single chemical detection is not enough. But as more pieces are found, the picture starts to form, and the gap between possibility and certainty becomes smaller. The difference between discovering life and proving it may come down to one moment, one observation that removes all doubt. Until then, scientists are left with clues that are too strong to ignore, yet not complete enough to confirm, which creates a strange situation. Humanity may already be surrounded by evidence of life beyond Earth, but it remains just out of reach, and that uncertainty leads directly into one of the most unsettling questions in science. In 1950, a physicist named Enrico Fermi asked a simple question during a casual conversation. If the universe is full of stars and planets, then where is everyone? That question never went away. It became one of the most unsettling problems in science, because all the evidence suggests that life should exist in many places. Yet the sky remains silent. No clear signals, no confirmed contact, no undeniable proof of intelligent civilizations. This contradiction is now known as the Fermi paradox. On one side, there are the numbers, trillions of planets, billions of years, endless opportunities for life to begin and evolve. On the other side, there is the silence. Something does not add up. One possible explanation is that intelligent life is extremely rare. Simple life may be common, but the leap to intelligence could be very difficult. It may require a long chain of unlikely events. On Earth, it took billions of years for intelligent beings to appear. Even then, human civilization is very recent. Another idea is more disturbing. Civilizations may not last long. As technology advances, the risks increase. Nuclear weapons, environmental collapse, uncontrolled artificial systems. A civilization could reach a certain level of progress and then destroy itself before spreading beyond its planet. This idea is often called the Great Filter. It suggests that somewhere along the path, from simple life to advanced civilization, there is a barrier, a stage that most life forms never pass. The question is where that barrier exists. It could be behind humanity, or it could be ahead. There's also the issue of distance. The universe is vast, beyond human intuition. Even if intelligent civilizations exist, they may be separated by distances so large. That communication becomes nearly impossible. Signals weaken over time. Travel takes thousands or millions of years. Two civilizations could exist at the same time and never know about each other. But distance may not be the only problem. There's another possibility that is even harder to accept. Advanced civilizations might not use technologies that humans can detect. Radio signals which humans rely on may be outdated for a more developed species. They could be using methods of communication that are completely unknown. signals that pass through space without being noticed. This means humanity could be surrounded by activity and still detect nothing. There is also the idea that humans are simply not ready. Technology is still limited. Telescopes can only observe certain wavelengths. Instruments can only detect specific patterns. It is possible that signs of intelligent life have already been seen, but not recognized for what they are. A signal could be dismissed as noise. A pattern could be ignored because it does not match expectations. History has shown that humans often miss important discoveries because they do not fit existing models. And then there is the most unsettling thought of all. Alien life may not be trying to be found. Some theories suggest that advanced civilizations choose to remain hidden, to observe rather than interact, to avoid interference, or to protect themselves from unknown threats. If that is true, then the silence is not empty. It is intentional, which leads to a chilling possibility. The universe may not be quiet because it is empty. It may be quiet because something is out there watching. The idea of alien life being close does not always mean a nearby star or a distant planet within reach of a spacecraft. Closer can mean something far more unexpected. It can mean hidden, overlooked, existing in places that were ignored for decades. Right now, within the solar system itself, there are worlds that were once considered completely lifeless, cold, dark, frozen solid. But recent discoveries have changed that view. Take Europa, one of Jupiter's moons. Its surface is covered in thick ice. From a distance, it looks silent and dead, but beneath that ice, there is strong evidence of a vast ocean. Not a small body of water, but a global ocean that may contain more water than all of Earth's oceans combined. And it is not just water. There are signs of heat, energy sources deep below the surface, possibly hydrothermal vents similar to those found on Earth's ocean floor. These vents on Earth are filled with life. Strange organisms that survive without sunlight, using chemical energy instead. That changes everything because it shows that life does not need a star's light to survive. It only needs energy in the right conditions. Another moon, Enceladus, orbiting Saturn, is even more surprising. It releases massive plumes of water vapor into space. These plumes contain organic molecules, complex chemicals that are considered building blocks of life. Spacecraft have flown through these plumes and detected them directly. This means that beneath its icy crust, there's likely a warm ocean filled with chemical activity, possibly life, and these are not distant worlds. They are part of the same system as Earth, close on a cosmic scale. Then there is Mars. Long thought to be a dead planet, it now shows signs of a more active past. Evidence suggests that liquid water once flowed on its surface. Rivers, lakes, possibly even oceans. Today, traces of methane have been detected in its atmosphere. Methane can be produced by geological processes, but it can also be produced by living organisms. The source is still unknown. It comes and goes in patterns that are difficult to fully explain. Then there is another layer. To this idea of closeness, life may exist at scales that humans do not easily detect. On Earth, microbial life dominates. It exists in numbers so vast that it shapes entire ecosystems. Yet it remains invisible without tools. If similar forms of life exist elsewhere, they could be present and active, but completely unnoticed. Even more challenging is the possibility that alien life does not follow the same rules. It may not be based on the same chemistry. It may not use water in the same way. It may exist in forms that do not match any known biological structure. This creates a serious limitation. Humanity searches for life based on what is already known. Instruments are designed to detect familiar patterns, familiar chemicals, familiar signals, but alien life may not be familiar at all. It could communicate in ways that pass through human technology without detection. It could exist in environments that humans barely understand. It could operate on timescales that feel too slow or too fast to notice. This means that being close does not guarantee discovery. It only increases the chances, and it forces a shift in thinking. Alien life is no longer expected to resemble plants, animals, or intelligent beings with technology. It may be something entirely different, something that does not fit human expectations in any way, which means the search is not just about looking farther into space. It is about learning how to see differently. The conversation has changed in a quiet but powerful way. Science is no longer arguing about whether alien life exists. That part is slowly becoming accepted. The real focus now is discovery. The universe is too vast to ignore, too old to dismiss, too complex to assume that life began only once and nowhere else. Every new planet that is found adds to the numbers. Every new molecule detected in space adds to the possibility. Every strange signal adds to the mystery. The evidence is not loud. It does not arrive with clear answers. It builds slowly, piece by piece, and each piece pushes the same idea forward. Life should be out there, and it may not be far. It could exist beneath frozen oceans and distant moons. It could be drifting in microscopic forms through space. It could be present on worlds that humans have already observed but not fully understood. The line between not knowing and discovering is becoming thinner. One new observation, one confirmed signal, one undeniable sign. That is all it would take to change everything forever. And that moment could come at any time. Not in some distant future, but within the lifetime of those watching right now, because the tools are improving, the missions are expanding, the search is becoming more focused and more precise. The silence that once defined the universe no longer feels empty, it feels unresolved, and that changes the question completely. It is no longer about being alone. It is about how close humanity is to finding the answer. If this made you think differently, take a second to like the video and subscribe to the channel for more deep explorations into science, space, and the mysteries that are still waiting to be uncovered. Because the next discovery may not just change science, it may change everything humans believe about their place in the universe.